So this is the titration of a weak base with a strong acid. This is very similar to the weak acid with strong base. The net ionic equation is going to be, oops, let's go with the pencil, a weak base like ammonia plus a strong acid, H plus, gives us ammonium ion. Okay, or F minus, weak base, plus H plus, gives us HF. So let's just talk about some key points. Before I've added any H plus at all, what do I have? Well, I have a weak base. How do we find the pH of a weak base? You make an icebox. And we've done that so many times, so I'm not going to get into that. Okay? All the points before I reach the equivalence point, but after I starting H plus. So for instance, if I took some ammonia and some H plus, I'd get some ammonium ion. Okay, and as just a random example, let's say if I started with 0.1 of this and I added half as much of that, right? Minus 0.05, minus 0.05, plus 0.05, 0.05, 0, 0.05. So before you get to the equivalence point, what do you have? Well, you have a buffer, okay? So just go ahead and plug it into your Henderson-Hasselbalch equation, and you're all set. Moles of acid, in this case NH4 plus, over moles of base. Okay, so nothing new there. At the equivalence point, okay, what do we have at the equivalence point? Right, so we've reacted ammonia with H plus to get ammonium. And if we're at the equivalence point, we've added the same amount of these. So the answer to what do I have at the equivalence point is I have a weak acid. Okay, when I have a weak acid, that means I need an icebox. I take my weak acid, okay, ionize it, and I might make my icebox. And keep in mind that you need to find your total volume, right? So that you can find the concentration of ammonia, all right, using these moles and this total volume. So then you can put in your molarity here, whatever it is, right? Okay, and then this is going to start to look pretty similar. Whatever your molarity was, minus x, x, right? And then this is a Ka, x squared, whatever that molarity was. Make your assumption, etc., and get your x. That'll be your molarity of H plus, and find your pH. Okay, so we can do some problems with that, but I'm not going to spend a lot of time because it's a repeat of what we've already seen. Beyond the equivalence point, all right, so for instance, again, you've got ammonia and H plus to give you ammonium ion. Okay, we're saying that now we've added more H plus than we had to start with. Okay. So I look at my final line and I say, what do I have? I have a strong acid and I have a weak acid. What do I do when I have a strong acid and a weak acid? I ignore this. Okay? And you know how to find. All right, you take the concentration, 0.05 moles, divided by whatever the total volume was, and you'll get your molarity, and then you get your pH. Okay? So again, I'm just kind of summarizing these. And then this is what your titration curve is going to look like. Okay? It's going to start high because we've started with a weak base. So the pH, you know, it's going to be up here somewhere. Okay? At the equivalence point, right? The pH is going to be less than 7, which makes sense, I think, right? Because you have a weak base and a strong acid, so the acid wins and you end up less than 7. Okay, you've also got this area in here that's going to be a buffer, just like when we had the weak acid, strong base. Okay, you can use the half equivalence point, right, and say that the pH at the half equivalence point will equal the pKa of your acid. Okay, and again, this rise area is a little shorter than it was with the strong, but so starts high and goes low, pH at the equivalence point less than 7, buffer area, and that's a summary of weak base, strong acid.